Hi guys, welcome to 3.7, Families of Quadratic Functions. You should notice if you're looking at your PDF, it's a little bit different than the one that I have here. I've added a flow chart. Don't worry, you already have it. It's already on D2L. It's section 3.2 flow chart. So you do have access to this. I want to quickly review it because today is a little bit of a longer section. It just takes a while to go through the questions. So if you need at any point, if I'm going too fast, please pause the video and then you can rewind and just kind of catch up any way that you need. So a quick refresher from the other sections. We've been looking at different forms of quadratics, and each form has its own little kind of information. We've got our vertex form over here, and the reason we like it is we can get our vertex from it. It is the h and the k value. If we expand and simplify and we collect all of our like terms, you end up in standard form. And we like standard form because we get the y-intercept as the c value. And then the third form that we look at is your factored form. We like it because we can get our roots or our x-intercepts, and they would be r and s. Okay, and we can switch from one form to another by factoring, expanding. If you wanted to go from one to the other, we can either complete the square, we can use our axis of symmetry, and then substitute it in. So we can switch from all these different forms. So once you have one form, you can just use any of your prior knowledge to get to the others. Okay, so let's look at today's stuff. Essentially what we're doing is we're creating equations of quadratics. So based on the information that the question gives you, you can create the quadratic with whatever form you need based on your information. So a question right here, they give us x-intercepts. Because they give us x-intercepts, I'm going to use the quadratic form that has intercepts in it. I'm going to use the factored form. So and then they tell us a little bit more information that it passes through this point over here. This is going to help us determine our a value. Okay, so let's get started. Here is my quadratic equation. And the first thing that I'm going to do is I'm going to substitute my roots. I know that I have an x-intercept of 1 and 3. That means that my r value is going to be 1 and my 3 value is going to be s. Keep in mind you have subtraction signs in your formula, so the signs here are going to be a little bit backwards. Okay? Step 1 complete. Now I need to figure out what the a value is. So I'm going to take the other point that they gave me, this -1, 16. -1 is an x value and 16 is a y value. So I'm going to substitute those into my equation. So this is going to be 16. I'm replacing y with 16 equals a. I still don't know what a is. And then instead of x minus 1, I'm going to have -1 minus 1. Okay. And then instead of x minus 3, I'm going to have -1 minus 3. So I'm replacing the x with my x coordinate. All right. Whoops. Helps when I put the right number in. There we go. And now what I'm going to do is I'm going to isolate for a, so we can solve for a value. So this is going to be 16 equals a. -1 minus 1 is -2. And -1 minus 3 is -4. Multiply the -2 and the -4 together, and then bring that -8 onto the other side. So 16 equals a times, oh, sorry, +8, right? -2 times -4 is +8. And then I need to get the a by itself. Because these are being multiplied, when you bring it onto the other side, you're going to divide. Now, I'm sorry, I don't have a fancy division sign here, so I'm just going to use the slash. Okay. So that is 16 divided by 8. You can reduce that and keep it as an answer of 2. So my a value is 2. Now, the question asked you to write the equation. There it is. So we still have to finish up our question. So I'm going to take my factored form of an equation. There it is, factored form. My roots would be 1 and 3, so it becomes -1 and -3, and my a value is now 2. I can just plug it in, and voila, there is your factored form of an equation. Okay, that's pretty much it. So the next couple questions, if you're happy with it, you can stop the video here. I'm going to do 2 more examples. They are going to get a little bit more challenging. One of them involves fractions, and then the other one is good old radicals, so make sure you put your thinking caps on for that one. Okay, let's move on. All right, write the equation of each of the following quadratic functions given the roots and the point. So we're going to continue working with our factored form. And let me copy this down. I'll need that down here later. All right, so here we go. Now, this and this are fractions. Before we plug them in, I want to remind you of something called the zero product principle. And I hope you remember me talking about it. If you don't worry about it. We're going to see it right now. Or we'll see part of it right now. Oops, pen. There we go. I want you to pretend for a second that maybe we have, I don't know, a quadratic like this. So you factored something, or they've given you something in factored form. There we go. And you are trying to solve. You have to set each one of these equal to 0 in order to figure out what the roots are. So let's just look at this one. If my brackets are 4x plus 7, I have to set 4x plus 7 equal to 0 in order to figure out what my root is. When you isolate for x, you're going to bring your 7 over. It would become negative. And then I have to divide by 4. Oops, sorry, 7 divided by 4. Okay. You should notice that you end up with a fractional answer. So something like this gives you a fractional answer. Take a look at what we have. We have fractional roots. Okay, so when you end up with a fractional root, it's because this number, this 7, is the one beside the, or being added or subtracted to the x, and the denominator is the number or the value in front of the x. Okay, and if you wanted to solve for the second root over here, you would do the same thing. You would also get a fractional answer there. Okay, and it's because there's a number in front of the 5. So when we come over here and we look at our factored form, I should go a times x minus r, and in this case, one of my roots is 2 over 3. And then the other one should be, let me put this in brackets, negative 5 over 2. Now, remember, your signs are going to be backwards. So this is a negative, this is positive. This is a negative. When you subtract a negative, it becomes positive. And I'm going to do that so I can get rid of the double brackets. Okay? Now, when I'm converting this bracket to get rid of the fraction, the 3, instead of writing it this way, is going to go in front of the x. Okay? And over here, the 2, I'm just going to take it away, and it goes in front of the x. Okay? So take a look. The denominator goes in front of the x. The numerator gets added or subtracted. Keep in mind your signs are going to be backwards. Okay? The 2 goes in front of the x, and the negative 5 gets added or subtracted, but the signs are going to be reversed. Okay, so now I've already got my bracket portion set up, and then the rest of the question would be like our previous example. Now I need to figure out what a is, so I'm going to take my x and my y coordinate from the point they gave me and substitute it in so I can solve for y. So 4 equals a, bracket, 3x minus 2, and then 2x plus 5. Now, instead of x, though, I would like to have negative 2, so I'm going to put a negative 2, and I'm keeping it in brackets, or another set of brackets, so I don't confuse my integers and my signs, okay? Keep in mind that you realize you are multiplying 3 and negative 2, not minusing 3 and 2. I know it looks crazy with all sorts of different brackets here, so let's make this a little bit nicer now. 4 equals a times, we can do this in one step. 3 times negative 2 is negative 6. Negative 6 minus 2 is negative 8. And the next one, 2 times negative 2 is negative 4. Negative 4 plus 5 is positive 1. Okay? I need to get the a by itself. I'm going to multiply these together and then bring them onto the other side. Because the negative 8 and negative 8 times 1 is negative 8. Because that's getting multiplied by a, the opposite of multiplying is dividing. When you bring it over, you are dividing. So this becomes 4 divided by negative 8. Okay, I'm keeping it in brackets, equals a. You can reduce 4 over negative 8 to become negative 1/2. Now, you could turn it into a decimal, but you're not going to because you know how much I love fractions and how much you love fractions. So keep it as a fraction. This is negative 1/2, not negative 0.5. Don't do that, negative 1/2. All right, so here's our a value. And we are going to rewrite our factored form of our quadratic to finish up the question, only instead of a, we're going to have negative 1 over 2 as a lovely fraction. Okay, and there you have it. All right, we're going to move on to one more. Make sure your thinking caps are on because it's just going to look a little bit messy at first, but once you get the hang of it, it's not too bad. So let's scroll down. We are going to find the factored form of a quadratic where my roots happen to have radicals in them. Don't worry, they're just numbers, okay? So this is the x coordinate, or one of my roots. This is the other x coordinate. It's my other root, okay? It might look messy for a bit. Let's just be patient. So I'm going to start off with my x minus r, x minus s formula. Instead of r, I'm going to have 2 plus root 3. Okay, let me copy this over here. There we go. All right, so this is going to be x minus, and I'm going to open up brackets, 2 plus root 3. Oh, that didn't work. There we go. Okay, and then we're going to have x minus in brackets 2 minus root 3. Okay. Yeah, I know it looks ugly. Don't worry, we will make this pretty in a second. We'll put some makeup on it, okay? All right, our job, regardless of what is written here, is to figure out what this a value is. So I'm going to eventually take x equals 1 and plug that in for my x values. And then I'm going to take y equals 2 and plug it in for the y value. You can simplify first or substitute right now. I'm going to substitute right now. Usually I substitute first, but it's just because of where we are, how we started. I'm going to substitute 2 in there, 1 for x, and 1 for x. And you'll notice that this already looks super crazy. Okay. All right, let's simplify inside my brackets. What I would like to do is take away this inner set of brackets. Remember, when you're subtracting a polynomial, you have to subtract everything inside the brackets. So we're going to write this down, but this time it's going to be minus 2 and minus root 3. Okay. In this set of brackets, it's going to be minus 2 and plus root 3. Simplify as best you can. Remember, when you're adding and subtracting radicals, you can only combine radical portions that have the same, you can only combine radicals that have the same radical portion. There we go. So 1 minus 2 minus root 3 will become minus 1 minus root 3. And this one over here would become 1 minus 2 is minus 1 plus root 3. Uh-oh. There we go. All right. This still looks a little bit crazy. I have to take this radical and multiply by this radical. Oh no, it's the distributive property, it's FOIL. But don't worry, look at all the lovely, something lovely is gonna happen, okay? I promise. So we're gonna have 2 equals a bracket. All right, negative 1 times negative 1 is positive 1. Negative 1 times root 3 is gonna give us positive root 3. Something did not go well. Hold on a second. Okay, found it. One small mistake. Negative 1 times negative 1 is positive 1. Negative 1 times positive root 3 is negative root 3. There we go. And now negative root 3 times negative 1 is positive root 3. And negative root 3 times positive root 3. Well, a negative times a positive is negative. Root 3 times root 3 is root 9, which is 3. Okay, and if you forgot those, go back, double check your radical work, okay? And this worked out nicely because negative root 3 plus root 3 is 0. That part is gone. So now we are left with something that looks so nice and pretty. We are left with 1 minus 3, which is negative 2. So 2 equals a times negative 2. To get this negative 2 onto the other side, we're going to divide it. So this becomes 2 divided by negative 2 equals a which is -1. So a equals -1. So we have our a value. We've got our formula up here. Just replace the -1 up top. Yeah, okay. We'll do this one, sure. There it is. Our a value would become -1. I would simplify inside these brackets just to make it look a little bit nicer. When you simplify, you should end up with, there you go, x minus 2 minus √3 and x minus 2 plus √3. Okay, and that should be your factored form of a quadratic. So it is possible that you can have radicals and deal with it. All right, we did the hard part. I'm going to just show you a quick example. There is the solution in your textbook. You can do this. Actually, maybe we should do this together. If I give you a table, simply create a quadratic. You should notice that something like this. Here, look, we will do this. It's okay. We'll be super quick. Pen. 0, 1, 2, 3, 4. I have to go all the way up to 22. 1, 2, 3, 4, 5, 6, 7. Okay, so maybe we'll go up by 3s. So 3, 6, 9, 12, 15, 18, and 21 is up at the top. Okay, so 0 and 1, something about there around. Now this isn't going to be great. 1 and 17, we're somewhere up here. 2 and 22 is just going to be right outside our grid. 3 and 17, 4 and 2. 1, 2, 3, 4. This is somewhere about there. Okay, you should notice you will get some type, some type of quadratic. Okay, do our best. There it is. Look how nice that looks. So we've drawn a scatter plot, check. We've drawn our curve of best fit, check. Find the location of the vertex. That is the location of the vertex. We can also find it in our graph. So our vertex is 2 and 22. Your job is to determine a quadratic function. So let's get typing. We're going to have y equals a x minus h squared, x minus h squared plus k. Let's just highlight this one up here, or superscript it. There it is. All right, substitute your h and your k value in. Oops. There we go. So in this example, instead of having x and y or x-intercepts with the factored form, they've given us a vertex. So we can use the vertex because it's a nicely identifiable point, and we can use it in our vertex form. So our vertex is 2, 22. So I'm going to replace h and k with 2 and 22. Keep in mind a positive 2 would result in a subtraction sign inside our formula. Our job, again, is figure out what a is. So use some other point. You can use the graph. I'm going to, again, use my table of values because there's a beautiful point, 0, 2 in there. It's easy numbers. I like easy numbers. So we're going to plug those in. So 0 for x, 2 for y. I guess technically it should be t and h for time and height, but I'm sure you can understand where we're going with this. So y value is 2, x is 0. We can super quickly solve for our a value. So this is 2 equals, okay, listen, -2 squared is -2 times -2. That's +4. So this is 4a plus 22. Bring the 22 onto the other side. Because it's being added, when you bring it over, it becomes a subtraction sign. 2 minus 22 is 20. I need to get the the 4 onto the other side. I am going to divide both sides by 4 to bring it over. So I'm just going to do this right now, divided by 4. And 20 divided by 4 is 5. So we've got our a value. Take this a value, substitute it in up here. And voila, you have the vertex form of a quadratic that follows these points. Okay? And just for a little bit of fun, there is a funny little thing about fractions. Guys, have a great night. I know that was a long one and a little bit of a tough one. Wish you all the best. We'll see you soon.